This video is looking at section Probability C. And in this section we're looking at the probability scale. Now probability values give the chance of an event occurring. The values must range from 0 to 1. Either an event doesn't occur, which would be a probability of 0, or the event is certain to occur, which is a probability of 1. So you can see this expressed here. 0 is less than equal to the probability of E, which is less than equal to 1. Probabilities can be written as fractions or decimals. Some people may express a probability as a percentage as well. An event that can never occur has a probability of 0. It means it's impossible. An event that is certain to occur has a probability of 1. So the probability of never equals 0, the probability of certain equals 1. So if we look at the probability scale here, you can see it can range from 0 to 1, where 0.5 in the middle would be a fair chance. So I've tried to give words here, where never, little chance, unlikely, fair chance, likely, very likely, certain. So in the example here it says place the following events on our probability scale. So winning lottery. Now the chances of winning lottery, unfortunately, are very close to 0. It's not that it can't happen, so we wouldn't go for 0, but we might go very close to it. A ball returning to the ground when thrown. I would expect that that would always happen, especially when we say what goes up must come down. So that would be, sorry, I'm using A and B, aren't I? Sorry about that. So this would be B and this is A. Rolling a 2 on a die. Well, rolling a 2, the probability of 2 is 1 in 6. There's a 1 in 6 chance of that happening. So if we looked at our scale here, this is 0.5, so that means 0.25 must be about there. Actually, there's an even easier way to see this. You can see that I've actually split it into 6. 1, 2, 3, 4, 5, 6. So 1/6 actually falls right there. It's a fine day in Alice Springs. Well, do we know much about the weather in Alice Springs? As far as I know, it's fairly dry, isn't it? But it can rain, so maybe we would have that down here. No, we don't have to be perfect here. It's more just giving an indication. Okay, last, tossing a head on a fair coin. Well, that's 0.5. 50% chance of that happening, so that would be in the middle there. Now probabilities can be assigned subjectively, which you saw with some of those with the probability of it being a fine day in Alice Springs, for example. Experimental probabilities, though, can be determined by observation of relative frequencies of the occurrence of a particular event E over long runs with many trials. So the probability of E would be the frequency of E over the number of trials we had. So for example, I might toss a coin and then count up how many times a 1 occurs in 100 goes. And you would expect that to be 1 in 6 because technically it's a theoretical probability. We can look at the sample space and we'll discuss that in the next section. But experimental probabilities, we might want to know what's the chance of it raining in Melbourne. And we might collect data across a year and then count up the number of days it rained. Okay, so that's an experimental probability. Whereas a theoretical probability, I might look at tossing a 2 on a die. Well, that can happen 1 in 6 times. Now there are also probability rules that can be used to determine probabilities for compound events, and we'll discuss those later in the module as well. So what now? Complete the exercise probability C1 from the textbook.